Good morning everybody. In this lecture we are going to see the problems of ionic equilibrium on the solubility and the solubility product. We know that solubility is nothing but the concentration of the solute dissolved in a solution, that is nothing but the solubility. But what is the solubility product? The solubility product is nothing but the product of ionic concentrations when the solute is dissolved in the solvent. Therefore, whatever the ionic concentrations are formed raised to the powers, the product of the ionic concentration raised to their proper powers. What these proper powers are? When we see the ionization reaction of any spherically soluble salt, therefore, the number of ions those are formed in the reaction, that much power, the number of times a specific ion is formed in the reaction, that number of time must be raised as a power in the solubility product. Therefore, if for example, we will take the example of magnesium hydroxide, which is a spherically soluble salt. If this is dissolved in water, therefore, this ionizes as Mg2 plus twice of hydroxyl ions. Here the number of the magnesium 2 plus ion formed is only 1, while the hydroxyl ion formed are 2. Therefore, the solubility product for the magnesium hydroxide, this can be written as the product of the concentration of magnesium 2 plus. Here only 1 ion of the magnesium 2 plus is formed, therefore power is 1 here, while the hydroxyl ions, twice they are formed, therefore the power 2. So this is what is the solubility product. Now the solubility, we had seen the equations, how the solubility product and the solubility are related. Therefore, and the number of the ions formed raised to the power, this is how the solubility is. This is the Mg2 plus this cation is formed only once, therefore the solubility of this ion is only 1, power is also 1. This ion is formed twice, so twice solubility raised to again 2, because here the power is 2. So this is how the relation of the solubility product and the solubility is. Here the solubility product for magnesium hydroxide will be equal to 4s cube, that means the solubility is 4 into solubility raised to 3. This is how the relation between the solubility product and the solubility is. Now we are going to see the problems. So the first problem, the solubility product of silver chloride in water is 1.56 into 10 to the power minus 10. Calculates its solubility at 25 degrees Celsius in grams per liter. See what we have given in the problem. Let's write the given data. Solubility product of silver chloride is given, and that is 1.56 into 10 to the power minus 10 at 25 degrees Celsius. Silver chloride its solubility product at 25 degrees Celsius is given. Why the temperature is mentioned here? Because the solubility product, rather the solubility of any salt depends on the temperature, and hence therefore the solubility products, they are specified at the definite temperature, because as the temperature changes, the solubility of the salt changes, and hence the solubility product. Therefore, this is the solubility of silver chloride at 25 degrees Celsius, and we have asked to calculate the solubility. Small s we have asked to calculate the solubility of the salt, and we have given the atomic weights of silver. Atomic weights we have given. Of the silver it is 108, and for chlorine it is 35.5. So this is what is the problem, and we have asked the solubility in grams per liter. We have asked the solubility in grams per liter. The solubility can be expressed in moles per liter as well as in grams per liter. So let's see how to calculate the solubility in grams per liter. See, now silver chloride in water, this will sparingly dissociate as Ag plus and Cl minus. Only one ion of the silver and one ion of the chloride will be formed. Therefore, the solubility product for silver chloride, the equation will be the concentration of the Ag plus ion into concentration of Cl minus ion. Only one ion of each are formed, hence their power are 1. Now therefore, in terms of solubility, if we try to calculate, these are only one ion, hence only once we take the solubility. So Ksp is equal to S square. And if you want to calculate solubility, S square is equal to Ksp. Therefore, S is equal to square root of Ksp. Simple. We know now this solubility which will be calculated from the solubility product, that solubility will be in the units of moles per liter. But we have asked to calculate the solubility in grams per liter. First, we will calculate the solubility in moles per liter from the solubility product. We know the solubility product of silver chloride. It is 1.56 into 10 to the power minus 10. Therefore, the square root of this is 1.25 into 10 to the power minus 5 moles per liter. This is what is the solubility. But the solubility we have calculated it in a moles per liter. So to calculate solubility in grams per liter, what we will have to do is solubility in moles per liter into molecular weight. This is what is the formula to calculate the solubility in grams per liter. Just multiply the solubility in moles per liter by the molecular weight. We know the solubility in moles per liter. Calculate it. The molecular weight. Now, here the atomic weights are given. So silver chloride. Only one ion is present, so 108 plus 25.5. That means 143.5. This is the molecular weight, and therefore the solubility in grams per liter is 1.79 into 10 to the power minus 3 grams per liter. So this is the solubility of silver chloride in grams per liter. Next problem. The solubility of magnesium hydroxide is 0.00835 grams per liter. Here we have given the solubility of magnesium hydroxide. This is what is the formula of magnesium hydroxide, and its solubility is 0.00835 grams per liter. See here, the solubility is expressed in grams per liter. Calculate the solubility product of magnesium hydroxide. Therefore, we have asked to calculate the solubility product of magnesium hydroxide. Now, we will first write the relation between the solubility product and solubility for this magnesium hydroxide. Magnesium hydroxide, it dissociates as Mg2 plus twice of OH minus, twice of hydroxyl ion. Therefore, solubility product will be equal to ionic concentration of magnesium 2 plus ion into ionic concentration of hydroxyl ion raised to the power 2, because 2 ions of OH minus ion are formed, and therefore in terms of solubility the relation will be, this will be only 1s, while this is 2s raised to 2. That means s into 4s square, that is 4s cube. 4s cube is equal to Ksp. This is what is the relation between solubility and the solubility product for magnesium hydroxide. Therefore, if you want to calculate Ksp, now here the solubility which is given, it is in grams per liter, and in this relation the solubility must be in a moles per liter. This is grams per liter. So if you want to substitute the solubility here, this has to be converted into moles per liter. So this is the solubility in grams per liter. How we will convert it into moles per liter? Therefore, what does this means? 0.008 solubility in moles per liter is equal to. In the former problem, what we had done? We had converted the solubility in moles per liter into grams per liter. For that, we have to multiply the solubility in moles per liter into molecular weight. Here what we will do therefore? Here we have given in a grams per liter. To convert it into moles per liter, just divide it by molecular weight. S in grams per liter divided by the molecular weight. The solubility in grams per liter is 0.00835 grams per liter. The molecular weight of magnesium hydroxide. Now here, to calculate the atomic weight, to calculate the molecular weight, we must know the atomic weights of magnesium, oxygen and hydrogen. Here the weights are given. Atomic weight of magnesium is 24, of oxygen it is 16 and hydrogen it is 1. Therefore, magnesium, here oxygen is twice and hydrogen is also twice. So twice of oxygen 32 plus twice of hydrogen 2. So this is 34 plus 24, it is 58. So this is the molecular weight of magnesium hydroxide, and therefore your solubility in moles per liter is 1.44 into 10 to the power minus 4 moles per liter. Now you can calculate the solubility product by substituting the solubility here in moles per liter. So Ksp is equal to 4S cube. So this is 4 into 1.44 into 10 to the power minus 4 cube. So this is equal to 1.2 into 10 to the power minus 11. This is the solubility product of the magnesium hydroxide. The next problem, calculate the solubility in grams per liter. Again we are asked to calculate the solubility in grams per liter of ferric hydroxide in water if its solubility product is 1.1 into 10 to the power minus 38. Solubility product for ferric hydroxide is given. 1.1 into 10 to the power minus 38. And we have asked to calculate S in grams per liter. Here we have given atomic weights. Atomic weights of iron is 56, of oxygen it is 16 and of hydrogen it is 1. Therefore, we will first calculate the molecular weight of ferric hydroxide. So iron is once, so 56 plus oxygen is thrice, so 48 plus 3. Therefore, the molecular weight of ferric hydroxide is 107. Now, ferric hydroxide, we know that it ionizes as price of OH minus. This is what is the ionization reaction. Therefore, solubility product for ferric hydroxide is equal to ionic concentration of Fe3 plus raised to power only 1 because only one ion is found here into ionic concentration of hydroxyl ion raised to power 3 because it is for thrice. In terms of solubility, S into 3S cube. So S into 27S cube. So 27S raised to 4. This is what is the relation between solubility product and solubility for ferric hydroxide. To calculate only solubility in moles per liter, what will be the relation? Let's calculate only for S. So KSP divided by 27 and only S will be equal to 4th root of KSP divided by 27. This is what is the relation to calculate the solubility in moles per liter. Let's substitute it here. See, this is what is the relation. 4th root of solubility product divided by 27. Let's substitute the solubility product. It is 1.1 into 10 to the power minus 38 divided by 27. So this is equal to 4.7 into 10 to the power minus 40. Its fourth root, and the answer is 1.42 into 10 to the power minus 10 moles per liter. This is what we have obtained the solubility, but in the units of moles per liter. Now to calculate solubility in the grams per liter, what is the formula? Just the solubility in moles per liter into molecular weight of the salt, that is ferric hydroxide. So 1.42 into 10 to the power minus 10 into molecular weight is 107. So solubility in grams per liter is 1.52 into 10 to the power minus 8 grams per liter. So this is what is the solubility in grams per liter. This grams per liter, what it means? This means that this much grams of the ferric hydroxide dissolves in 1 liter of solution at given temperature. The temperature taken here is 25 degrees Celsius is the temperature considered here. At this temperature, only this much grams of the ferric hydroxide dissolves in 1 liter of the solvent, that is the water. Next problem. Calculate the amount of silver chloride would dissolve in 1 liter of boiling water if its solubility product is 1.4 into 10 to the power minus 4. See, we have given the solubility product 1.1 into 10 to the power minus 4. Now, this figure is different than the formula. In the first problem, we had seen the solubility product for silver chloride, and that was very less. The value was 1.56 into 10 to the power minus 10. This is 1.1 into 10 to the power minus 4. How come? Here, the solution of the water solvent is boiling. That means it is at the temperature of 100 degrees Celsius. The solubility of any salt is depending on the temperature. As the temperature increases, the solubility of the salt increases, and hence therefore this is the solubility product of the silver chloride, which is very much greater than at the 25 degrees Celsius. This is the solubility of that salt at 100 degrees Celsius. Because here the boiling water is considered. Obviously we know that the water boils at 100 degrees Celsius. At boiling water, we have asked to calculate the amount of silver chloride dissolve in 1 liter. At this temperature of 100 degrees Celsius, how much amount of silver chloride will dissolve in the water that we have asked? That means here simply we have asked to calculate solubility in grams per liter but at the temperature of 100 degrees Celsius. Therefore, simply KSP, that is the solubility product for silver chloride, is equal to the concentration of Hg plus ion into concentration of Cl minus ion. Now we will write it in the terms of solubility. Simply S square. Therefore, S is equal to square root of KSP. So let's first calculate the solubility in moles per liter. From this formula, we will get the solubility in the moles per liter. 1.1 into 10 to the power minus 4, which is equal to 1.18 into 10 to the power minus 2 moles per liter. We have asked the amount of silver chloride dissolved in 1 liter. That means we have to express the solubility in grams per liter. How many grams of silver chloride will dissolve in 1 liter of water at 100 degrees Celsius? This we have asked. That means we have asked S in grams per liter. So to calculate it, we know the formula: solubility in moles per liter into molecular weight of silver chloride. So 1.18 into 10 to the power minus 2 into molecular weight 108. So this is equal to, this is only the molecular weight of atomic weight of silver. The molecular weight of silver chloride is 143.5. So 1.69 grams per liter. What does this mean? This means that 1.69 gram of silver chloride will dissolve in 1 liter of boiling water.